Formalin, a colorless solution with a pungent odor, is often misused as a food preservative despite being harmful to health. This substance cannot be digested by the body and can cause irritation, poisoning, and even death. In the long term, formalin damages organs such as the liver and kidneys and is both carcinogenic and mutagenic. In Indonesia, some foods such as tofu and salted fish found in traditional markets are contaminated with formalin in relatively high amounts, between 65% and 70%, highlighting the need for monitoring formalin levels in food.
Indonesia is rich in biodiversity, one of which is the red Asoka flower or Ixora L, which has mainly been used as an ornamental plant. Several studies have revealed the potential of this flower in medicine, including its ability to detect formalin. This research aimed to further explore the potential of Asoka flower as a formalin detector, focusing on the reaction and change that occur when the flower interacts with formalin.
We, Ivon Meliana and Salsa Putri Study, students from UPN Veteran Jawa Timur, are motivated to find a solution to the increasing use of formalin in food, which pose a health risk. By utilizing the potential of nature, we choose the red Asoka flower, which contains anthocyanins, a natural compound that can be used as a formalin detector. Based on this research, we have compiled a scientific paper titled Utilization of Anthocyanin from Red Asoka Flower or Ixora L as a formalin detector through formaldehyde oxidation to enhance food safety, which we hope will contribute to improving food safety.
The extraction of red Asoka flowers begins by selecting 30 grams of high-quality flowers, which are placed into a 150 ml beaker and mixed with 60 ml of solvent. The mixture is heated to boiling for 15 minutes. After that, the filtrate and residue are separated using filter paper and the filtrate is stored.
In applying the red Asoka extract as a formalin detection liquid, formalin samples are placed into test tubes according to the treatment's variables. The red Asoka extract is added, and the mixture is stirred until homogeneous. The mixture is heated for 2 minutes or until air bubbles appear, then cooled, and the color change and reaction condition are observed. Stability and reactivity tests of the red Asoka extract liquid are conducted using the same method.
The addition of Asoka flower extract acts as an acid catalyst that accelerates the oxidation reaction. In this reaction, aldehydes react with oxygen to produce carboxylic acid, water, and precipitate CX as impurities. The use of Asoka flower extract enables the detection of aldehyde through color change and precipitate formation. The aldehyde oxidation reaction is a process in which an aldehyde group, FCHO, is oxidized by oxygen to a carboxylic acid, FCOOH, producing water as a byproduct. This reaction is characterized by a color change from red to purple, which serves as a visual indicator that the aldehyde has undergone oxidation.
The extract of the Asoka flower mixed with formalin forms a purple precipitate resembling rubber in the final product. This precipitate forms because the organic compounds in the extract do not react when heated to the saturation point, causing heavier clumps to form and settle at the bottom. Stability tests of the extract show that the higher the concentration of formalin used, the more precipitate is formed, indicating a more intense reaction between the substances. To improve the accuracy of the extract in detecting formaldehyde, we conducted reactivity tests under acidic and alkaline conditions. The results were very interesting. The extract turned dark red when mixed with acidic solution, while with alkali solution, the color turned yellow to green. More notably, the extract remained stable and unaffected by heating, but before and after this process. This shows that this liquid extract is very stable and effective in detecting formaldehyde.
Comparison of the iris spectra between the Asoka flower extract and the remaining reaction liquid shows significant differences. The extract contained a CC double bond alkane group, which was not found in the remaining reaction liquid. In contrast, the residual liquid showed the presence of CO double bond alkene groups and carboxylic acid groups, which were not present in the extract. This also explains the pH test result that ranged from 4 to almost 7, indicating a chemical reaction that produced a weak acid, as evidenced by the presence of carboxylic group identified as formic acid in the iris spectra.
Anthocyanins are natural pigments that give plants their red to purple color. including cyanidin-rich Asoka flowers. Anthocyanin color is influenced by pH, where in acidic condition or pH 1 until 3, it will appear red, while at pH above 4, it turns purple or violet. Formalin, with its acidic nature and pH of around 2 until 3, is able to maintain the red color of anthocyanin because it keeps the flavellum cation structure stable.
The results of the study have been conducted and standardized as listed in the following table. In conclusion, based on the consideration of the results of 5 and B5 treatment are the best treatment because they show significant color change.